Hi guys, gonna do a little lesson on lines of symmetry and some of the polygons. I also want to say that I miss you guys a lot. This isn't fun. I miss going in and making each other laugh and all that, but I guess this is the norm for a little bit. So let's get into the lesson of symmetry. So when we did some of it last week, some of the examples that were shown were, okay, here's a square. You had your vertical symmetry, and that was just if you were folding it in half. You had your horizontal symmetry, you could fold it in half that way. This is a special polygon. Or diagonal symmetry, okay? And we showed some things that did not have symmetry. Like let's take my brother Phil here. Okay, Phil has symmetry. Vertical, but if you got him this way, oh no, don't do that, and you folded it in half, would that be the same? No. So we just have to look at how we fold things and also rotating things. So sometimes if I know it's going to be hard for you to do on a computer, I get it, but try to visualize if the shape was on a different side. And I'm going to show you a perfect example of that with a triangle. Okay, I cut these out instead of me trying to draw them and then being all over the place. So most people can look at an equilateral triangle and see that an equilateral triangle has a vertical line of symmetry. Okay, and I see that by, if I fold it in half, there you go. Both sides match. But, check this out. Let's turn it. Uh-oh. All sides are equal, so we'll have another line of symmetry. Right here. Let's try that. Parker, get down. Both sides are the same. Let's try rotating it again. See, we have another line of symmetry right here. Fold it in half. Both sides are the same. So, how many lines of symmetry does an equilateral triangle have? It has 3. You know what, I'll do the square next because we already kind of started that. So your square, don't leave the magnet, and then your diagonals. Okay, so you have 4. Look, you could fold it this way, and it is the same. This way is the same. Fold the corners, since all the edges are the same, we're all congruent. And this way. So you have 4 lines of symmetry on a square. This one gets people a rectangle. Piece of paper is rectangle. I didn't have to cut anything out. Okay, so we know we have a line of symmetry here and here. Okay, let's try it. Fold it in half. Both sides are the same. Both sides are the same. But a lot of times people think that the rectangle has the diagonal line of symmetry the same as a square. Let's try it. Okay, so if I'm going to fold the 2 ends together, are both sides the same? No. You have that little strip which looks like another little triangle up there. You have a little triangle on this side. So a rectangle will only have 2 lines of symmetry. Here's another one. We have another 4-sided figure. It's small, I'm sorry. This was the only one I could get to print correctly. And that is a parallelogram. Now, a parallelogram has 4 sides like the square, and it has 4 sides like the rectangle, but it has 0 lines of symmetry. And let's show that, okay? So, if I try to fold it in half, I'm left with a triangle here and a triangle here. So, that is not a line of symmetry, okay? Let's try folding it this way. Here again, that doesn't work, and I'm left with a triangle on the side, so it doesn't match up. Let's try our diagonals. That also doesn't work, and I'm left with a triangle on the top and a triangle on the bottom. So, parallelogram has 0 lines of symmetry. Now we'll try all sides the same, a rhombus. Okay, so it's a special parallelogram. This one, I can't fold this way horizontally because I'm left with a triangle on each side, or vertically because I'm left with triangles on both sides. But this is, like I said, a special parallelogram. What happens if I try the diagonals? If I fold the rhombus on their diagonals, I'm left with a triangle which matches on both sides. Alright, let's try the long, or seemingly longer. There we go. So a rhombus, special parallelogram, has two lines of symmetry. We have a trapezoid. A trapezoid, if I try to fold it this way, I'm going to be left with the two triangles. It's not going to work. The diagonals also aren't going to work. So this one pretty visibly has your one line of symmetry right down the middle. And here we go. So a regular trapezoid has one line of symmetry. Now, if we were to draw one of those weird trapezoids, right, and we know this is a trapezoid because it has one pair of parallel sides. And any quadrilateral that has at least one pair of parallel sides is going to be a trapezoid. But this one does not have any lines of symmetry, okay? Just like with the triangle and the equilateral triangle had the three lines of symmetry, if you were to have, say I have an isosceles triangle, it wouldn't work the same way. I should have done that in the beginning, but I'm sorry. And then finally, we have a hexagon, okay? Hexagon has 6 sides. This is a regular hexagon. So we have our line of symmetry from point to point. We have our line of symmetry from point to point. Line of symmetry from point to point. Okay, and if we fold that, here we go. These are all the points, right? See, side. Okay. But we also can't forget, and this is where rotating the shape would come in handy. And again, I know you're on your computer, so I'm sorry. But we could also go halfway through 1, 2, 3. Okay. And they are still going to be congruent. Symmetry. Fun stuff. What if I were to draw like a, here's a turtle. Kind of. Oh, that was a bad one. Let's put the head over here. Okay, so that would have a line of symmetry. But if I were to draw a, I don't know. I'm giving you a problem on your homework for tomorrow, sorry. If we have a seahorse, man, that's a good seahorse. This does not have any line of symmetry, okay? From at least that angle. All right, see you guys. I miss you.